In this video, we will refactor our player input to comply with open-close principle. So I'm going to open up the script. Okay, so we can see that our player input relies on this movement input vector and on interact event action delegate. And the code inside the update, inside the get mouse input and get interact input is relying on Unity's input manager. So we would like to have a way to extend this code by implementing a way to get input from our buttons on the screen for the mobile version of our game. So what we would like to do is to extract an interface from it and make sure that our player relies not on the concrete implementation of our player input, but rather on the interface. And this also gives us the opportunity to introduce the dependency inversion principle. So those principles are tied together very strongly, so if you apply one, chances are that you will apply another one as well. But still we have in mind our open-close principle, so instead we want to make sure that our player doesn't get the player input, but instead an interface, and then whenever we want to change the version to be mobile, we are going to drag simply a component responsible for getting the input from the buttons on the screen rather than from the Unity's input manager. So let's go back to our player input, and what I'm going to do is copy those two fields. If you have Visual Studio, you can simply right click on the player input and use the quick actions and refactoring and use the extract interface, which will allow you to extract the player input with those two fields. If you are not using the Visual Studio, let's go back to Unity. Great. And simply we could create a new C# script inside our scripts folder. Let's call it movement input, for example. And let's open this script up. Great. And here we are not going to derive from model behavior. Instead of the class keyword, we are going to use interface keyword. We are going to delete all of those methods inside this class, this interface, and we are going to paste what we have copied. We need to delete the encapsulation keyword, so public, because inside the interface everything is public. And what we are going to do is click on action, Alt-Enter, and say using system. And we cannot have a private set here, so we are going to delete it. So we have only this property movement input vector. Now do mind that you cannot have fields inside the interface, you can only have properties and events. Great. I'm going to copy the name of the interface and go back to the player, to the player input. Okay. And if you have used this refactoring from Visual Studio, you should already have it, but if you don't, just paste comma after the model behavior and paste the name iMovement input. And this is how we have implemented the interface, so those two fields. So what we can do now to decouple our player from our concrete implementation of player input is we can copy the name and go to our player script. I have it opened in Visual Studio. Great. And what we will want to do is instead of getting access to the player input, we are going to get access to our iMovement input. I'm going to refactor the name to movement input. I'm going to slide down to the start function, and we can of course get the player input, but instead we are going to get the component iMovement input. And now nothing breaks in our player. And by the way, we need to refactor our player since this ties the whole code for our player. So this player is not going to comply with open-close principle. So we are going to need to modify it whenever we want to add something new to our game. And this is the fact that for our architecture, you could create something better here, some better architecture, but with this architecture, the player will never comply with open-close principle because we need to modify it every time we add some new functionality, some new module. Since this is a type of controller object that will control the flow of information through our system. Okay, so with that in mind, we have extracted the interface from our player input, and now we can get it, and everything should work still. So now we can extend our player, so the functionality of our game rather, by simply going back to Unity. Great. We could create a new C# script. Let's create player mobile input. Okay. We can open it up. So player mobile input. Okay. We are going to delete all the methods from here. After the mono behavior, we can add comma and call I movement input. Alt enter and say implement interface. And now we have two parameters, our movement input vector and on interact event. What we can do is simply, instead of throwing an exception, we can add a get and private set here. And this should be fine. Okay. And this is our property, this is our delegate. And now we would simply go back to Unity. Okay. So I have prepared a bit of a panel with some input controllers, so with some input images for our mobile input. And I have created a mobile movement button method that extends iPointer down handler, which is from Unity Engine event system and iPointer up handler. And I have added some functionality to our player mobile input, so we can get movement input, and we can set the movement input vector to the direction passed to this method. We can have interact input, so it calls on interact event invoke, and we have reset input that resets the input to be vector to 0. And I'm using the panel and couple of images with the mobile movement button script, and they have assigned field mobile player input, and we have a movement direction, and this is simple vector 2 with values 1, -1 for down, left x is -1, and right is x is 1. And we are calling this mobile movement button, and when we are on pointer down, so when the player holds down the mouse button on the pointer or on the image, we are calling input get movement input and passing it this movement direction that we have set inside the buttons. And when we let go of the pointer, so when we let go of the button, we are resetting the input to be vector to 0. And our button, interact button, has a simple reference to our player mobile input and calls on it interact input. Okay, so now I have only swapped the player input for player mobile input and added this player mobile input to our player. And this all will be available on GitHub as the package, so we can download it and use it in our own project. But basically what it will do is when we press play, we will be able to press those buttons and move around. So just as we would use on the mobile, and we can press this button to interact. Okay, and to go back to our keyboard input, we should simply disable this panel and go to our player and remove this player mobile input. So remove this component, add player input, and we can press play now, and we should be able to use our keyboard instead to move around and our mouse button to interact. So this is how we would implement the open-close principle to extend the functionality of our input. Now in the next video we will tackle a different matter. So if we stop the game and take a look at our player AI interactions, we have this if statement that checks what kind of enemy is, what kind of NPC is the target, Reika's target. And you can see already that this would be bad if we have added more NPCs with more functionality or different functionalities. We would have this class, the player AI interactions grow and grow, and we can do it much better by implementing inheritance for our NPCs. So this class will only ask for the abstract version of NPC and call on it, for example, interact. So that's what we are going to focus on in the next video. Now, if you are enjoying this video, leave a like, leave a comment, and I'll be seeing you in the next video.